Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a multiple choice question with one or more correct options on angular momentum of a body and the torque acting on it. The question is as follows. Torque acting on a body about a given point is given by tau is equal to A cross L, where A is a constant vector and L is the angular momentum of the body about that point. Then it follows that the options are A. dl by dt is perpendicular to L at all instants of time. B. The component of L in the direction of A changes with time. C. The magnitude of L does not change with time. D. All the above choices are correct. Before proceeding to solve the problem, let us recall the related concepts. Cross product of two vectors. Consider two vectors A and B acting at a point making angle theta with each other. If C is equal to A cross B, then the magnitude of C is equal to AB sin theta and the direction of C is perpendicular to both A and B, which implies that C dot A is equal to 0 and C dot B is also equal to 0. Therefore, it follows that the component of C in the direction of A or B is equal to 0. Dot product of two vectors A and B is given by A dot B is equal to AB cos theta. Now, the angle between A and A is equal to 0. Therefore, we have A dot A is equal to A square. Now, the torque acting on a body is equal to the rate of change of its angular momentum. Therefore, we write tau is equal to dl by dt. If the component of torque in a given direction is equal to 0, then it follows that dl by dt in that direction is equal to 0. Therefore, angular momentum remains constant in that direction. Now, we are in a position to solve the problem in the question using these concepts. It is given in the question that tau is equal to A cross L. Now, let us examine the options one by one. For option A, by the rules of cross product, we have tau is perpendicular to L. Also, we have tau is equal to dl by dt. Therefore, dl by dt is perpendicular to L at all instants of time. Therefore, option A is correct. For option B, we have tau is perpendicular to A. Therefore, we have dl by dt is also perpendicular to A, which implies that the component of dl by dt in the direction of A is equal to 0. Therefore, the component of L in the direction of A remains constant. Therefore, option B is not correct. Now for option C. To obtain information about the magnitude of L, we proceed as follows. we have L dot L is equal to L square. Differentiating both sides with respect to time, we get d by dt of L dot L is equal to d by dt of L square. This implies dl by dt dot L plus L dot dl by dt is equal to 2L dl by dt. Since dot product of vectors is commutative, we have dl by dt dot L is equal to L dot dl by dt. Therefore, we have 2L dot dl by dt is equal to 2L dl by dt. Therefore, L dot dl by dt is equal to L dl by dt. Now, according to the question, tau is perpendicular to L. Therefore, dl by dt is also perpendicular to L. This implies L dot dl by dt is equal to 0. Therefore, we have L dl by dt is equal to 0. But L is not equal to 0. Therefore, we have dl by dt is equal to 0, which implies L is equal to constant. That is, magnitude of angular momentum does not change with time. Therefore, option C is correct. Hence, option D is not correct. Therefore, the correct options are A and C. This completes the answer to the question.